Let's go ahead and look at an example that uses repeated factors, and we're going to look at the case where those factors are linear. The ones that are repeated are linear. Let's go ahead and look at this example. On top, we have x squared minus 4x plus 12, and on the bottom, we have x cubed minus 4x squared plus 4x. Let's go ahead and just work with our denominator. We want to go ahead and factor. We realize that each of these has an x in it, so let's go ahead and take the x out. This is going to give us x times the quantity x squared minus 4x plus 4. The stuff inside our parentheses is still able to be factored, so let's go ahead and go one more step and factor that trinomial. The trinomial is going to factor into x minus 2 and x minus 2. So when you take a look at this denominator that we just factored, you'll notice that the x minus 2 is a factor that repeats. That's what we mean by repeated linear factors. It's linear because our highest degree here is a 1 on those x's. Let's go ahead and break up our fraction. Now this one's a little bit different than the last example we looked at. I have my fraction here. I left my denominator this time in the factored form, just so it makes it a little bit easier moving forward. And when we go to set up our fractions, we're going to be taking each factor that we had here in the denominator. So my first fraction is going to be a over my x value. My second fraction is going to be b over the x minus 2. And for my third fraction, I have to account for the fact that this is a factor that repeats. So I'm going to have the fraction c over x minus 2, this time the quantity squared, because I see that it appears twice. Now we can go ahead and start solving for our a, b, and c values. Remember that we want to go ahead and get rid of our denominators, so we're going to multiply both sides of this equation by our denominator here, x times x minus 2 times x minus 2. And remember that we're going to be multiplying both sides by this, and I'm going to go ahead and write out the steps the long way. Let's start with our left-hand side. Right? We're going to be multiplying our left-hand fraction here by the x minus 2, and the x minus 2 again. That was our kind of first distribution step here. And when we do that, everything here on top is going to cancel with this entire denominator. And we're going to be left with x squared minus 4x plus 12. Now when we start going to the right-hand side, let's take each step as we see it. In this first part, when I'm working with this fraction, this x in the denominator is going to cancel with that x. And for this piece, I'm going to be left with a times x minus 2 times x minus 2. Let's go ahead and take a look at our middle portion here with the b's, right? This x minus 2 in my denominator is going to cancel with one of these sets of parentheses, the x minus 2. And we're going to be left with b times x minus 2. And for our third set over here, the x minus 2 quantity squared on the bottom is going to cancel with the x minus 2 quantity squared on top. And we're going to be left with c times x. Now remember that we eventually want to solve for a, b, and c, so let's be a little bit strategic about how we do that. Remember that there's a lot of different ways you can approach this part of the problem kind of moving forward. One way we can do it is to go ahead and pick an x value. If I'm taking a look at my problem here, maybe I want to get rid of this a term, and in order to do that, I can pick an x value of 2, because that's going to cause this to become a 0, and 0 times a is going to make that entire term disappear. So let's start with that piece and pick an x value of 2. Remember that we want to plug it in every time we see an x in our equation. Now when I let x equals 2 If I start here on this left-hand side and plug in, I'm going to get 2 squared minus 4 times 2 plus 12. That's the piece that you see right here. I'm going to keep my a value there, and I'm plugging in 2 for each of these x's. So I'm going to get 2 minus 2 and 2 minus 2. I'm going to plug in 2 for the rest of these x's here, so b times 2 times 2 minus 2. And my last slot here is going to be c times 2. Now let's go ahead and simplify where we can. I wrote a lot of my work out here. If I simplify this left-hand side, I'm going to end up with a positive 8. And when I go to simplify the stuff on my right, these two pieces came out to be 0, which is what I wanted, and I'm going to have a 2c. So I'm at the equation 8 equals 2c. I can divide both sides by 2, and I'm going to end up with a c value of 4. Now we still need to solve for our a and b values, so I went back to this line, and let's take a look at our equation again. I'm going to go all the way over here to the end. Realize that if you plug in a 0 for this x value here, your c term is going to disappear. So hopefully that's going to allow us to solve for either a or b. So let's try letting x equals 0 and see what happens. I plugged in 0 for each of my x terms. Now let's go ahead and simplify what we have. We're going to end up with an equation that says 12 equals 4a, and if we divide both sides by 4, we're going to end up with an a value of 3. Now we have 2 out of the 3 letters that we're looking for, and we still need to find our last one. Now we still need to solve for b. When we were taking a look at our sets of parentheses here, and we picked our x value of 0 and our x value of 2, that was strategic in the sense that it eliminated some of the other letters that we were working with. In this case, we're allowed to pick anything we want for our x value, anything other than 0 or 2, since we already used those. That way we can solve for our b value. Keep in mind, we're allowed to plug in the other numbers that we know. We already know the a value and the c value, so if we need to use that, we can. So let's go ahead and make this easy on ourselves. Let's just pick an x value of 1 and see what happens. Now when I do this, I'm going to be plugging in 1 for my x value, and at the same time, I'm going to utilize those other 2 letters that we already found. So I'm going to replace my a with the number 3, and I'm also going to replace my c value with a 4. That way, by the time we plug all 3 of these in, we should be able to solve for b. There's everything plugged in. Let's go ahead and simplify the pieces that we can. Once I simplify, I'm going to end up with an equation that reads 9 equals 7 minus b. Let's go ahead and solve this for b. We should end up with a b value of negative 2. Now that we have all 3 of our letters, let's go ahead and write our partial fraction decomposition using our a, b, and c values. So here's our final breakdown with our a, b, and c values plugged in. Keep in mind your general formula here is going to have all plus signs in here. The reason that you'll see this minus sign is we had a b value of negative 2, so when I plug my b value of negative 2 in there, I could have a negative 2 over x minus 2. Instead of writing it as a plus here and then a negative on top, I went ahead and simplified my signs just to make that a minus sign in front of that term. Make sure that you plug your a, b, and c values into the appropriate slots.